Week 1, Lecture 8. Functions in Julia. 1. We split our lectures in Julia into two parts. In the first one, we're looking at built-in functions and a couple of general issues around functions. So functions in Julia are very important. We've already seen this particular example. So the function println received the input, which is the value of a variable, and it did something which was to make something happen on screen. Most of the time we use functions to generate numerical values. So here is a case of three different examples: cos, log, and abs. They generate three different values. If we separate them with commas like this, technically speaking in Julia, in the right hand side we're making a tuple and we're assigning it to the tuple on the left hand side, but in fact what really happens is simply that we've simultaneously assigned to the three variables a, b, c the three values that we created. There's the first value. Let us insert a cell and see what we mean. If we say a, there's the value a. So a is the cos of 0.2. b, 2.302, is the log of 10. This is log to the base e, the natural logarithms. Finally, abs is simply the absolute value of minus 1.22 is plus 1.22. Julia is a functional language, and that means that in a very important sense the basic unit for organizing code is the function. The type of, for instance, is a function. It provides information which in other languages is not obtained by functional means. You can read the Julia code, that is, really, you can read all the code for Julia in julialang.org, and you'll see that almost everything is done via functions. So when you write your own code, you should also organize it as functions. The question of user-defined functions happens in the next lecture. Command line help is a lovely feature that Julia offers. We simply enter a question mark and after it a topic that we want information about. So let's see what it says about cos. Well, it says that cos of x computes the cosine of x and that x must be in radians. So that very usefully tells you how you should be using x. If we ask for help on help, let's see, is that helpful? Well, no, unfortunately it's not very helpful. It sends you to some websites. So it tells you where you can go to get help, but it doesn't actually really give you any particular help. Let's look at another help for a particular function. This is for computing histograms. The interesting point here is that it gives us help on hist v, e, and then also help on hist v and then square brackets. Rather than e, we have something else. So either this square brackets is a convention that is used in this help, whereby this is optional. So you could just have v by itself, optionally using n bins. So you can have v or v, n. So here e is a range of edges for the bins, and the vector length of the result histogram. Use this often. Whenever you have functions that you're wondering about, ask about it. The built-in mathematical functions in Julia are actually very numerous. This is quite a small sample of the possibilities. There are three that have to do with exponentials and logarithms. If you want to work to base 10, you use log 10. This is the natural logarithm. Exp is also the natural exponential, so exp of x is e to the x. Cos, we've seen, the argument must be in radians. Cos, sine, and tan, they're the usual one. A cos is the inverse, the arc cos, and it returns to you a value in radians. Interesting thing about arctan is that there are two possibilities. You have atan and atan 2. This mimics what many other computer languages does. Atan returns only angles between minus 90 and 90 degrees, minus pi over 2 and pi over 2 radians. So that's not all possibilities. If you want angles from quadrants 2 and 3, you have to use two inputs, the x and the y value, and not just the actual tan. And for that you use atan 2. If you want to do operations that turn real numbers into integers, floor and ceil are a way to do that, and many, many, many more. Round is a very general one to do that. And you can explore all of these using the question mark query method that I mentioned above, and I really, really strongly urge you to do that. If you think that a function may exist, and you think it starts with the letter D, then what you can do is give the letter D and then press tab. And now you get a whole lot of possibilities. It turns out there's something called Dawson. It's probably a function. A discrete cosine transform. You can deconvolve. If I use the up and down arrows, I can delete with an exclamation mark. And a whole lot of things, and you would want to look them up and see whether they are a function that do what you want done. So these are the basics of functions in Julia. Let us turn very briefly to multiple dispatch. Very often we actually want functions that are quite similar, but they operate on slightly different values. So cos of 1 without the full stop means it's cos of an integer, and cos of 1 point with a full stop means it operates on a float 64. These are different code bodies because integers and floats are dealt with differently in the computer. The result in both cases is the same, but the actual code doing the calculation is different. So we want cos of 1 to go to the code for int64 and cos of 1 point to go to the code for float 64. So the way Julia determines what to do is that it allows all these different methods and it chooses the correct one depending on the input type. Because the input type of all the variables in a Julia function are used, this is called multiple dispatch. So if you look at the function muladd, we can ask how many input types does it allow? Methods is the way to do that. So the function methods is here applied to the function muladd, and it turns out that muladd can operate on an input x, y, z, in which they're all float 32, they're all float 64, or they're all float 16. And then there are two more general ones. These are abstract types. So muladd can also accept abstract input of slightly different kinds. They will run at different speeds. So many of the bugs you can expect to see when you program in Julia will arise because you're calling functions with a type signature and there is no method. You have to fix your code, of course, and there are two ways you can do that. You can change the input values that go to the function so that they now have the correct type signature, or alternatively, you can change the function by adding an additional method to do the required type signature. So the first one, where you change the input values, you're not changing the function, but in the second one you are changing the function, so that will be a user-defined method, so it'll be part of the next lecture.